So we want to find two numbers such that the product of two positive numbers is 140, and we want to find the two numbers that will yield the minimum sum. So here there are a couple of keywords, and more importantly, the most important word is the minimum. So that means we are dealing with an optimization problem. So we want to minimize a function. So remember what we do when we see that's an optimization. The first thing is that what is our goal? And our goal is what I call the objective function. So here we want to find two numbers. So the two unknowns are the numbers, which I'm going to call x and y. And we want the two numbers such that we have a minimum sum. So we want to minimize the sum. So our objective function is the sum being addition, then it's going to be S, I'm going to call it S for sum, x plus y, where again, x and y are the two unknown numbers. But remember, there's infinitely many solutions here. I mean, minimum, no. If you're dealing with positive 0 and 0 will be, but we do have some constraints here. We don't want two numbers that yield the minimum sum. Again, if the two numbers were positive, then 0 and 0 will be what we want and we finish. But here we have a constraint. And the constraint is the fact that we want the product of those two positive numbers. So remember, x and y here will be greater than 0. And we want the product to be 140. Product means multiplication. So, and again, the two numbers are positive. Technically 0 is included, but because a product, which is a multiplication, is 140, that means neither x nor y could be 0. So here we constraint is x and y are both positive, and then the product, which is multiplication of those two numbers, so x times y is 140. So this is what we have. It's always like this. The first step you do is figure out your objective. Here we want to minimize the sum. So we write the equation for the sum, the expression for the sum, sorry. And then we are usually given constraints within the problem. And here we found the equations that relate the variables. And in order to minimize or optimize, we're going to have to find the critical number of a function, but we can see here the sum is a function of two variables. We haven't seen multivariable calculus yet, so here that means we're going to have to rewrite our objective function, the sum, x plus y, in terms of either x or y. And how do we do that? Is by using the constraint equation. See, we have an equation that links x and y. So we solve either for x or we solve for y. So here I'm going to solve for y, and here I get y equals 140 over x, which means my sum, which is x plus y, then I can replace the x plus y, the y, I can replace it into, we can replace it into the sum. And so here that means that the function we're going to be working is the sum x equals x plus 140 over x. And now we have a function of one variable, meaning that it's function of just an x. So the way we find absolute extrema, we need first to find the critical numbers. So the first thing we do to find the critical numbers, means that we're going to have to find a derivative. So I'm rewriting s in a way that I don't have to use rule beside a power rule. So I bring the x in the numerator by rewriting 1 over x as x to the negative 1. And now I can differentiate very easily, and we get 1 minus 140 x to the negative 2. And remember, to find the critical numbers, we're going to have to do two things. Solve an equation. So when we're trying to solve an equation, never leave your expression for the derivative or for the function with a negative exponent. So here I'm rewriting as 1 minus 140 over x squared. And we want this to be equals 0. That's how we find the critical numbers. We set it equals 0. So this is equivalent to 1 equals 140 over x squared. And here, if you multiply both sides by x squared, 1 times x squared is x squared. 140 over x squared times x squared is 140. So we see that x is going to be plus or minus the square root of 140. But here, remember, our constraint is that x must be positive, so that means that the negative, I'm gonna reject it. So I'm gonna cross it out. And remember that so that's one critical numbers. That's how we find it, by taking the derivative and set it equals to 0 and solve it. But also remember, the critical numbers is where the derivative is undefined. So we look at the domain of S prime, and we see that we are dealing, when we revise 1 minus 140 over x squared, we have a rational expression. A rational expression, its domain will be all real number except where the denominator is 0. Well, the denominator is 0 at 0. So that means the domain will be all real number except 0. So here, that means we have another critical number to add is 0. But for the same reason that we rejected the negative square root of 140, because we were dealing with positive number, and also at the beginning I had that discussion, x or y cannot be 0, because that means that the product of x and y will be 0. So that means we have to reject it. But we always have to do this. Remember that we do need to find the critical numbers, we need to find where the derivative is 0, but also we have to explore the domain of the derivative. So we only have one critical number. So here I'm going to check that we have a minimum there, and if we have a minimum there, then it would be a local minimum, but there's no other minima, so that means that will not only be a local minimum, it's going to be actually being an absolute minimum. So for that, I'm going to use the second derivative tests, which means that I'm going to take the derivative of s prime. So this is just derivative of 1 is 0, and again I'm using this version of s prime, so I don't have to use the quotient rule. That would be negative 140 times negative 2x to the minus 3, which is 280x to the negative 3, which I will write like this. And we see that this, as long as x is positive, then the double prime is going to be positive. And again, you can just plug into your calculator, but you can see it's 280 over the cube of the square root of 140, and this is positive. So remember here, what does that tell us? The sign of the double derivative tell us about the concavity of the function. So the double prime is positive. So remember, as the little diagram we have, the double derivative is positive. That means the function is concave up. So it looks like this, right? Well, here that means that this is part concave up. So that means that right there you can see that you do have a minimum right there, because at that point x equals 100, square root of 140, the function is concave up. So you have a local min, and as I said, because there's no other critical number, that local min is actually an absolute mean. So we found the value of x that will yield to the minimum sum. And then remember, the question was to find the two numbers. So I found x is square root of 140. So that means that to find the y, well, remember we have an expression here, we solve for y here, y was 140 over x, so I just plug in, replace x by 100 of the square root of 140, and then after simplification, y would be 100, the square root of 140. So the two numbers that yield to a minimum sum are the square root of 140 and the square root of 140. They are both positive, and indeed their product is 140. So that answer satisfies all the constraints of the question, and we prove that we had an absolute minimum by using the second derivative tests.